Hello, and in this video we're going to be looking at proving something that we stated earlier and that we've been memorizing. Now, this isn't something that you need to kind of force yourself to learn off by heart. It's more sit back and appreciate the maths and remember a rough outline of how we approach it. So here we're looking at the curve with equation r equals p plus q cos theta, where p and q are positive constants and p is greater than q. So prove that the curve is convex. So convex is when it looks like here. We've been calling that the egg shape. So it is convex for when p is greater than or equal to 2 times the coefficient of cos theta. And it has a dimple, so it looks like this, when p is less than 2q. Now, the way that we're going to prove this is we're going to look at the vertical tangents, so the ones that are perpendicular to the initial line, and essentially we're going to be using the fact that if it is convex, then there is only going to be 2 coordinates for that tangent line, or if it is a dimple, there will be more than 2 coordinates for the tangent line. So here, because we're looking at the vertical one, we're looking at having dx by d theta is equal to 0. So that means we're going to look at x is equal to r cos theta, and well, x is going to be equal to p plus q cos theta times by cos theta. So x is equal to p cos theta plus q cos squared theta. Well, let's differentiate that. So dx by d theta is going to be negative p sine theta. And, I don't want to differentiate cos squared, or do I do? Do I want to differentiate cos squared? Yeah, let's differentiate q cos squared theta. So that is going to be 2q cos 2q times by cos theta. I'm using the by parts, differentiation by parts. So that's going to be 2q times by cos theta multiplied by the differentiation of cos theta, which is negative sine theta. So here we can make that look a little bit better. We're going to factorize out negative sine theta from here. So we've got p plus 2q cos theta. So I'm saying that this is equal to 0, which means either sin theta equals 0 or p plus 2q cos theta equals 0. So if sin theta equals 0, well, that just means that theta is equal to 0 or pi. So that looks pretty good for here. We've got when theta is 0, we've got when theta is equal to pi. Or if we look here, I am recording a video. We've got cos theta is equal to negative p over 2q. You've now made Simon jumpy. You're still staying in the room. Okay. Sorry for the interruption, guys. So here, this is the important one. So this here, I've got 2 solutions. My question is, what's going on here? I've got 3 things that could possibly happen. So I could either have p is less than 2q. So if p is less than 2q, then I've got negative a fraction. So when I've got negative a fraction, that means I'm going to be finding solutions in these 2 quadrants. Because if cos theta is a negative fraction, that means it's going to have solutions here and here. Oh, I forgot that there'd also be a tangent line there, wouldn't there? So here, if P is less than 2Q, then I have solutions for this. That is going to be a dimple. So that gives me the 4 solutions I need for there to be a dimple. Or I can have P is equal to 2Q. If P is equal to 2Q, that means cos theta equals -1. If cos theta is -1, that means theta equals pi. I've already got that. So that's still just those solutions. One of them's repeated, so that means I've only got 2. That is going to be a convex curve. That's going to look like an egg. Or I could possibly have P is greater than 2Q. If P is greater than 2Q, then I've got no solutions, because that would be cos theta is a number greater than 0. So if there's no solutions for that, I've still only got these 2 solutions. So that is also going to be convex.